Okay, here we're going to do an example of using implicit differentiation to find the slope of the graph of an equation at a particular point. Okay, so our equation is x cubed times y cubed minus y equals x. So this equation here defines y implicitly as a function of x. Okay, so I know that as x changes, y will change. And so I'm going to use implicit differentiation to find y prime, or dy dx. So I'm going to differentiate each side with respect to x. Okay, so we're going to find the derivative of this side by finding the derivative of this and then subtracting the derivative of this. To get the derivative of x cubed y cubed, we need to use the product rule. So we have the derivative of the first times the second plus the derivative of the second times the first, then minus the derivative of y, and that equals the derivative with respect to x of x, which is just 1. Okay, why don't you press pause while you work on these derivatives? Okay, the derivative with respect to x of x cubed is just 3x squared, so times y cubed, plus the derivative of y cubed with respect to x is going to be 3. We keep the inside, subtract 1 from the power, multiply by the derivative of the inside, and then times x cubed, minus y prime is simply the easiest one to do. If there's nothing else there, just the y with the prime on the outside, that's exactly y prime. So that is equal to 1. Okay, now we need to solve this equation here for y prime. We see that there's a y prime there and a y prime there. So we're going to put everything that doesn't have a y prime attached to it on the other side. So that means we're going to subtract both sides by this. Okay, next we're going to factor out a y prime on the left-hand side. So we're left with 3y squared x cubed minus 1, and that equals this. And the last thing we're going to do is divide both sides by this quantity that's being multiplied by y prime. Okay, these two cancel, so we're just left with this for y prime. Okay, so now we should go back to the question, and it says find dy dx at the point 0, 0. So that means we plug in 0 for x and 0 for y. And we get zeros in there, 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 and there. So this whole term is 0, and this whole term is 0. So in the numerator we have 1 minus 0, just 1. In the denominator we have 0 minus 1, which is negative 1. So the slope of the graph at the point 0, 0 is negative 1.